A solar eclipse happens when the moon's shadow falls somewhere on the surface of Earth, and a lunar eclipse is the opposite, when the Earth's shadow falls on the moon. The two sections of the shadow, the dark umbra and the partially shaded penumbra, their placement determines which type of eclipse we can see from Earth. But not all eclipses are made equal. The most spectacular, the one for your bucket list, is a total eclipse of the sun. A total solar eclipse begins as a partial eclipse. You'll notice trees projecting the crescent sun and shadows becoming sharper than normal. The landscape darkens to a bluish gray, and you'll start to feel the temperature drop. From the west, the moon's shadow rushes towards you like a silent storm. Look up, and you'll see the last sliver of the sun sparkling like a diamond ring before it's broken into a string of beads by the moon's rough terrain. Now you can see the pearly glow of the sun's corona and the pink and red light from the hydrogen gas of the chromosphere. Together, these make up the sun's outer atmosphere, and a total solar eclipse is the only occasion you have to lay eyes on it. This is totality, and if you get a chance to see it, you should. The moon orbits Earth every 29.5 days, but we don't get eclipses every month. That's because the moon's orbit isn't in line with Earth's orbit. It's tilted about 5 degrees. That doesn't seem like much, but keep in mind that the scale of the model we're showing to you is way off. If the Earth and moon are this size, the distance between them should be around 10 feet. At this distance, 5 degrees is enough to keep the moon's shadow off of Earth and the Earth's shadow off the moon most months. So why do we ever get eclipses? Because there are 2 points where the moon's orbit crosses the sun's plane, called nodes. And as the Earth moves along its annual orbit, those points line up with the sun about twice a year. As the moon passes between the sun and Earth at that time, we get a solar eclipse. And when it's behind Earth at that time, we get a lunar eclipse. There are a ton of orbital quirks that make predicting eclipses really complicated, but in general, we'll have a few solar and a few lunar eclipses of some sort every year. But you're more likely to see a total lunar eclipse in your lifetime than a total solar one. The totality of a lunar eclipse can last well over an hour, and it's viewable for anyone on the night side of Earth. The moon often turns red during a total lunar eclipse because our planet's atmosphere scatters the bluer wavelengths of light while the longer, redder wavelengths pass through. Or to put it another way, a total lunar eclipse projects all of the world's sunsets and sunrises onto the moon. Total solar eclipses seem much more rare because totality lasts just a few minutes, and although Earth gets a total solar eclipse every 18 months on average, each one is only viewable by less than 0.5% of Earth's surface. Eclipse chasers travel all over the world to put themselves in the path of that shadow. In a total solar eclipse, the moon precisely covers the sun from the vantage point of some place on Earth. This is possible because, by coincidence, the sun and the moon appear to be about the same size in our sky. While the sun is 400 times bigger than the moon, it's also about 400 times farther away. But this alignment isn't constant. The moon has an elliptical orbit. Its size varies about 12% throughout the month. When it's closer to us, we can get total solar eclipses, but less than 30% of solar eclipses are total. More often, we get partial eclipses, where the alignment is a bit off, or annular eclipses, where the moon is too far away to fully block the sun, leaving a ring of sunlight around the moon. In the far future, Earth will only get annular and partial solar eclipses because our moon is moving further away. We know that because Buzz Aldrin and Neil Armstrong left mirrors on the moon in 1969. Astronomers bounced lasers off those mirrors to measure the moon's distance, and that's how they found out that the moon is moving away from Earth by more than 3 centimeters per year. So in a billion years or so, whatever creatures live here will witness Earth's very last total solar eclipse.
We can see on the radio on the screen a fantastic total solar eclipse taken from the pictures above the clouds.
Fabuleuse en bas et à l'ouest, c'est probablement sensationnel.
Der Chef der Sternwarte-Linie, was fühlt man in so einem Moment, Herr Philemon? Ja, super.
This is just fantastic.
A lot of early civilizations feared eclipses. They were seen as an attack on the sun or moon by the forces of darkness. But now that we understand our place in space, eclipses are an occasion for awe and for gratitude. All over the galaxy, rocks are casting shadows on other rocks, but only here, as far as we know, Is there someone to notice them?